Hello everyone, and thanks for watching Edupedia World videos. In this video, we'll discuss solutions to problems in the first paper of the 2014 JEE Advanced Physics question paper. I'll be following questions as they fall in code 1, but in any other code, the questions will just be shuffled up so you can match them for yourselves. Let's move on to question 10. We are given a circuit. I'll just draw that first. Okay, so this is V1, this is V2 with polarity opposite of that of V1, R3, R2, R1. So two ideal batteries, three resistances. We want the current and resistance R to be 0. The current in this resistance to be 0. Obviously, there are many ways to solve the standard circuit equation. What I always like to try to do is try to assume one negative potential to be 0 and go from there. Because you can set any one arbitrary to be 0 and that takes care of one less variable. Right, instead of having 5 variables where only the difference matters, you can set 1 to 0 and you have 4 variables. So I'll just set this to 0, which means the potential here is 0. And then the potential here has to be V1, right? And the potential here has to be V1. And the potential here is V1. And the potential here is then, this is positive V1 and then another positive. So this is V1 plus V2. And this is 0. So, I made a mistake. This will be some V dash, or let's take it to be V3, right? So this is V3 plus V2, right? We cannot say the potential here will be the same, right? Because this is going through a resistance. So here over a wire it will be the same, here it won't be the same. Now, for the current in R2 to be 0, these two should have the same potential. That means we want V3 to be 0. That means we want this to just be at V2 and this to be at 0. Well, what does that mean? If the current here is 0, current is going in this direction, coming in this direction. No current is going in this branch, it's going in this direction, going in this direction, coming in this direction. So the current through this resistance has to be the same as the current through this resistance, which means V1 by R1 is equal to V2 by R3, or V1 by V2 is equal to R1 by R3. Any set of V1, V2, R1 and R3 that follows this combination will result in there being no current in R2. So we can just look at this. Option A satisfies this. So A will be true because the ratio everywhere is 1. For option B, V1 and V2 have the same ratio as R1 and R3. R2 doesn't matter. You can just remove that from the equation. For C, V1 by V2 is 2 and R1 by R3 is 1 by 2, not 2. So it is false. And for D, V1 by V2 is 1 by 2 and R1 by R3 is 1 by 2. So D is true, which means the answer is A, B and D. Thank you.